All right, so let's get started. Today, so you should be depositing your requirement document. And if you're ready, you can submit your homework 1. If you're not ready, you have until Sunday to put it in, which basically, in that case, you use up all your 3 late days. Okay? So in terms of...
Isn't the homework due at midnight tonight?
No, it's right now. But
2
minutes.
minutes.
Oh,
Because I'm pretty sure it said somewhere that it was due at midnight.
Oh, it's 12
p.m.
Oh.
So it should be 2 minutes ago.
Yeah, but you
Oh,
have,
well.
you have your late days. That's why we have late days, so that you can shift your homework time around to some time you like. All right. In terms of material, we are basically in the ballpark of design, high-level design, detailed design. We're going to continue with our discussion from last time. So this is your transition from requirement document into your design, and eventually into implementation. So you can see that we're going to spend almost 3 weeks on design issues. So lastly, we're going to talk about classical analysis, basically a technique we have used before. So for instance, if you are in the business of programming using C, you still need to go back to many of the traditional classical analysis techniques, right? So here, we had a pretty big emphasis on Java object-oriented analysis. However, it would surprise me if some of you get a job to do C programming, right? So if you are programming anything that smaller than a laptop, you're probably going to get into somewhat C programming. Even for laptop and phones, if you are doing a lower part of the software stack, you'll be using C. So that's actually a critical piece of information we need to have. For instance, so I'm pretty sure among all the software languages Intel is using right now, I mean, the most popular one should still be C. Okay, so certainly they use Java, C++, and all these good things, but I'm pretty sure they have a good amount of C programming still going on. So that's why we're going to look at a classical design method. Then we're going into implementation and testing eventually methods. All right, so let's recap what we were last time, pretty much. So essentially, our handover from the requirement stage to design stage, or you can call it analysis stage, or design stage, high-level design, low-level design, what have you. Essentially, we are starting off with a requirement document. That's basically what you guys put in today, right? So essentially, what's the purpose of requirement document? It's a way for you to document your interpretation of the requirement. At the same time, it's also the document you share with your teammate, so that you can have a teamwork going. They don't have to come to you every time. And so certainly you need your own documentation. At the same time, you also need to give your teammates or other teams something to start off with. And that will be our requirement document. On a higher level, use case is one way to give a high-level overview of your requirement document. Okay. So let's interpret this use case diagram again. So it's actually pretty straightforward. We have the system we are trying to build, which is MSG Foundation Information System. Okay, that's a system we are building. Then we also identify who are the users of this system. In this case, we have the staff members. We have the borrower. If analogy we can use here is, if you go to PSU's cache counter, right, or record, so transcript, so those places. If you talk to certainly the staff member, they are using PSU information system. Part of that information system not available to you. You can use that system, but you have to go through your staff member. Same idea, all right? Then all these nice things that we have here are basically tags we are putting on the system and say, hey, you need to provide these functionalities, these features out of your system, okay? In terms of your application, so you also have a list of features you must provide. Number one, I mean, when new user come to you, you should be able to allow the user to register. User registration is certainly is a feature, a use case. A user login is you should be able to log in people so that they can use their app. They start using your app, get authenticated. Then you also should be able to allow them to send messages to everybody in the chat group, or you can send to one person in the chat group, and you should be able to retrieve a chat that has happened before. Okay? See, these are the features you need to provide. And we will be checking whether you have those features in your requirement document. We'll be checking whether you have implementation of these features in your design document. We'll check whether you test these features in your test document. We will test whether you really have those features or not in your final code. Okay? So that is the purpose of requirement document. All the design, testing, implementation we will be doing will be based on this document. That's why it's so important. So this is essentially the contract. Although in our discipline, the contract changes quite frequently because the user wants you to change, right? User don't come to here and demand the change to their house all the time, but they do come to demand change for their software all the time. All right, because the nature of software that can be easy to change, right? Once you sign a contract to build a house, right? If you build with a contractor, if you make any change, you basically have to provide an addendum to your contract, so essentially you are entering a new round of negotiation with your contractor to see whether you can add new feature or not. Typically, adding new feature means that you have to pay more money. Okay, which is not always true in our case because, well, basically software. I mean, your user has the expectation of if it's not major change according to them, you should be able to accommodate those changes. Okay, but no matter what, all the features eventually you should have a finalized contract everybody can accept, and you use that contract all the way through your development process. Once this contract is nailed down, essentially, in so that's why we don't have a contract signed essentially for 2 years. We have a contract essentially signed for 2 weeks. Okay, you as a project manager or product manager can probably protect your development team for 2 weeks, but really no much longer than that. What that means is, for the 2 weeks, you are not changing the requirement, but the next 2 weeks. Good luck. Highly likely the requirement will change. Okay, so that is the nature of our business. All right. If we can understand what it is about, then we can go into our high-level design phase, which is okay. We'll look at one use case, which is a manage a mortgage use case. We'll look at one scenario. What is a scenario? A use case basically is a category of things that you can do, similar things grouped together. A scenario is just one of the possibility paths of that feature. Okay, manage a mortgage. In this case, I mean, so the staff member entered a new value of annual real estate tax. Information system updated date on which the annual real estate tax was last changed. Okay, So one of the possibility, another scenario may be the staff member entered the mortgage number incorrectly. So in that case, you need to handle that situation, right? If you don't handle that situation, then your system is incorrect. Okay, that's why you want to enumerate all these scenarios. The second scenario, so there's a change in weekly income. Then we'll update that information. Again, there are a possibility of the mortgage number is wrong, or the borrower didn't bring sufficient documentation for their new income, right? So these are possible. So these are normal situation, and these are things that can go wrong. Here we are essentially we are trying to cover all the possibilities that could appear when people are using our system. The normal situation and things that can go wrong. Okay? Most of the time, actually, for us on our level, we can get the desired correct behavior implemented correctly. However, our program from you guys are typically pretty fragile, which means that if I change anything with respect to input or anything, any way to use your system, the system breaks. Okay? That's why you need to cover all these different possibilities. Again, this is coverage. Essentially, so we always have a coverage. You must have always coverage concept in mind. So when you come up with a requirement document, your use case should provide a full coverage of the original English spec. So basically, your user or another tester or QA or somebody, or your colleague, shouldn't be able to point to one piece in that requirement document or original English spec and say, look, this information is not covered by your requirement document. That's how you get point deducted. That's how you get you're criticized by your colleague or your manager for not completing the right requirement document. Actually, the standard is very easy for the grader and for the project manager. They can say, okay, your document is wrong because this piece of information in the original English text is not covered by any of your use case. Okay, make sense? So we are doing one level of document on the other level. We're layering it on, but they all need to cover the document that appeared before. Because if you don't cover all the information you have before, then you are making mistakes. Plain and simple. You may actually make the mistake of doing too much, more than you need. That's a possibility too. But in that case, we're not going to punish you, and your customer typically would not punish you either. It's in the case when I originally have 5 things need to be covered, you only did 4. Okay, 1 outstanding, then that's an incorrect requirement document. Again, the same thing happens if I'm coming up with a high-level design. If there are some information in the, for instance, I missed the use case, clearly wrong. I didn't miss the use case, but I missed the alternative, wrong too, incorrect. Because you are supposed to provide 100% coverage of all the use cases and all the normal situation and abnormal situation in your design. If there's anything that's not covered, you made a mistake. Are we clear? That's how you determine whether your design is a correct design or not. Whether your design is a good design or bad design, that's a totally different story. Okay? However, correct and incorrect design really means whether you have all the functionality identified and implemented in design or not. Good design, you may say, oh, this one is more efficient, more energy efficient, more memory efficient, just looks beautiful in terms of GUI. That's additional thing, okay? For us, the most critical thing is coverage. If you leak information, you lost information along the way, okay, then your design is wrong. Your code is wrong, and so that is an incorrect requirement, incorrect requirement document, incorrect design, incorrect implementation. If you are losing information from the original spec, okay, that's how we can tell. All right, one more scenario for estimate fund available for the week. We're not going to detail there. You look at all these scenarios, basically trying to provide a 100% coverage. All right. So then you have so in this stage, okay. Now, the most important thing in high-level design is to identify the modules, the components that should be in your system. In our case, because our system is small enough, our components are basically our classes. So here, critically, we are trying to identify classes, because that's the component we have in our system. How do we do that? Very simple grammatic analysis. We are using non-extraction. Basically, because non capture the information that need to be held, stored, processed. Intermediate result we need to hold in our system. We identify those things. We identify the nouns that are important. Either they are going to be a class or they're going to be attributes of the class. Okay? These are essentially information we need to store in our system. Then we come to, okay, we need to hold information about mortgage. We need to hold information about investment. Look, this is the foundation, which basically does two things. One thing is they are going to put out mortgage, okay? Give people mortgage. Essentially, then people repay the mortgage, or they are going to put their money in investment. Okay, their assets are pretty much in the two forms. Okay, so these are essentially, if you look at it, that will be their asset. Okay, so these are the classes. How did we get them? Basically, we look at all the nouns and say what are the most important critical things that must be there in our system. For a noun in your original spec, either they are going to be a class or attribute, or you classify them as superficial, no use. Okay? You may actually say, oh, guess what, I made a mistake. That's the wrong classification, I get it back. Don't throw them away. They are always there in the backup. Okay? Then once you have the classes, the next step is for you to add attributes, which are information savers. That's where you put your information. Just like when you program, your variables are essentially where you save your information. Okay? Your variables are where you save your information. When you define a Java class, the attributes are essentially where you save the permanent information. At least permanent in terms of, if I don't shut down your program, that information is in the memory, right? So basically, for us in software engineering, there are two critical things: data and operations on the data. Attributes are essentially the data. And your classes are essentially groupers. They group a number of attributes together because they are related to each other. Okay? All right. So if we look at, so then you may actually, in some cases, say, okay, once I try to identify the classes, I'm actually thinking maybe I should just change some of the requirements and shrink it down. Here I'm not going to have manager mortgage, manager investment. I'm just going to have one thing called manager asset. Okay, so this is an example of different designs. Is there a way to say these two designs, which one is actually better? Which one is actually worse? You would have to come up with some kind of criteria to do that judgment. but both are actually acceptable design. Okay? Some people may think one is better, the other people may think the other one is better. However, they are all acceptable design. Why?
Because
They are all acceptable, they are all correct. Why they are all correct, but some people like something better, some people like the other thing better.
they both cover all
Exactly.
cases.
Perfect. That is the fundamental thing. I actually covered everything in the original spec. Yeah, I can implement this way or that way. But hey, I covered them all. Both design are acceptable. Okay? I'm not advocating one design over the other, actually. Up to you. All right, so now we actually can assign all the attributes. Basically, these are the data store information we need to keep, right? For instance, you better know what kind of investment you have, how much return, and when you update that return. And you better know who has that mortgage, right? If you give money out to somebody and give somebody a loan, and you don't even know who they are, I think the chance you'll get the money back will be probably close to zero, right? Just like you take $1,000 and just hand it over to a random person on the street and say, I gave you this loan and remember to pay me back. The chance they will pay you back, yeah, there exists some chance, but I think it's small, right? So you better keep that information. That's why these are information. Attributes are essentially how we keep information. Your classes are essentially groupings. Group all this information because they are related. Questions? This is basically how you identify the basic components of your system. That's your classes. Your classes are holder of information in terms of their attributes. At the same time, because we are doing object-oriented design, the very nature of object-oriented design is that you group the data here